Good morning, Sir Monico Gul here, and also to my fellow BSMB students. As you know, this morning is the day that we would like to present our assigned topic about solution. The next thing is we will tackle about the general properties, strength of solutions, and lastly, units of concentration. But before that, I will introduce to you our group mates. Shane Mulet, Nisi Joy Moring, Lee Antoinette Simagala, John Philip Bergantin, Jun Ray Hinampas, Angela Capotol, Famela Tutor, Regian Inuhalis, Claire Atchacoso, Ira Ayag, and Adeline Sansoles. Shane Mulet will be the first one to discuss about what is the solution. I will discuss the examples of solution. Lee Antoinette Simagala will discuss the two main parts of solution. Then Nessie Joy will discuss the types of solution. After the solution, John Philip and John Ray will follow and discuss what the general properties are. Then the strength of solution will follow, and lastly, the units of concentration.
Hello, good morning. So today I will be discussing about solution. So what is solution? A solution is a type of homogeneous mixture that is made up of two or more substances. A homogeneous mixture is a type of mixture with uniform composition. This means that the substance cannot be distinguished easily from one set to another. When we think about solutions, the first thing we think about is substance dissolved in water. This is natural because, after all, water is the universal solvent. However, solutions are not limited to the liquid phase, but solutions can exist in the gaseous phase. The air we breathe is a solution that is composed of a mixture of gases. Solutions are also present in the solid phase. Broth is a solid solution that is a mixture of copper and zinc.
I will be discuss the examples of solutions. Some examples of solutions are soda, tea, metal alloys, seawater, air, gasoline, mercury silver, rubbing alcohol, sugar in coffee, and salt in water. When you look closely, upon mixing salt with water, you can't see the salt particles anymore, making this a homogeneous mixture. The next is air. Air also is an example of gas solution. The main component of air is nitrogen. Mixed into the nitrogen gas are many other gases, such as oxygen, which we can breathe, carbon dioxide, which causes climate change. The carbonated water also is an example of a solution where the gas is the solute. And lastly, solutions can also be a gas dissolved in liquid. There are many other common solutions that we interact every day. And those are the some examples of solutions.
Once again, good day, sir. This is a continuous report of our topic. So let me make use of our salt water example to talk about the two main parts of a solution. So these are solute and solvent. Solute, this is a substance that makes up the minority of the solution, or this is a part that is dissolved. In our example of salt water, the solute is the salt, and the characteristics of solute. A solution is a homogeneous mixture of two or more substances. The solute particles in a solution are not visible to naked eye. A solution does not cause light beams to scatter, A solution is stable. The three forms of solute are gaseous, liquid, and solid. While solvent, this is the substance that makes up the majority of the solution. This is the part where the solute is dissolved. In our example of salt water, the solvent is water, and the characteristic of solvent has the low boiling point and gets effortlessly dissipated. Solvent have shading and smells. Solvent help to manage the temperature of a solution. And this an example of a solvent include water, ethanol, methanol, and acetone.
Good day, my name is Nisijui Moring, reporting to you the types of solutions based on the state of matter of the solvent and solute in the solution. It can be classified as one of the multiple types. For example, a solid. Solid solution would involve a mixture of two or more solid compounds into a solution, while liquid gas solutions involving mixing a gas and a liquid to make a solution. Let us examine these different types of solution and discuss some well-known example of each type. And first example of type of solution is solid solution. Generally involve melting two or more solid and high temperature mixing, and then letting them cool solidify. Example of solid solutions include first is brass, a solid solution metal alloy containing copper and zinc, and the second is bronze, a metal alloy that is a solid solution of tin and copper. And the third is sterling silver, a metal alloy that is a solid solution of silver and copper. Second types of solutions is liquid solutions. Involve mixture of two or more miscible liquids that dissolve in one another. Example includes first is vinegar, a solution of water and acetic acid. And second is hand sanitizers, a solution primarily consisting of ethanol mixed with water. And the third is antifreeze, a mixture of water and ethanol glycol. The third types of solution is gas solutions. Involve a mixture of two or more substances in the gaseous state. Example includes air. The air in our atmosphere is a solution of multiple gases, primarily nitrogen. Second is natural gas, a solution of various gaseous organic compounds, namely methane, ethane, butane, propane. And that's all about my topic.
Discussing about physical change properties of solution. But first, what is physical change? It is a change in state or properties of matter without any accompanying change in its chemical composition, such as dissolution and dilution. What are the properties of a solution? A solution is a homogeneous mixture. The constituent particles of a solution are smaller than 10 to the power of negative 9 meters in diameter. Constituents particles of a solution cannot be seen by naked eyes. Solutions do not scatter a beam of light passing through it, so the path beam of the light beam is not visible in solutions. Solute particles cannot be separated by filtration. Solute or solvent particles do not settle down when left undisturbed. Solutions are stable at a given temperature. Solubility. This refers to the amount of solute that can dissolve in given amount of solvent of a specified temperature to produce a saturated solution. So there are four types of solubility: the saturated, unsaturated, supersaturated, and crystallization. Saturated. It contains maximum amount of solute that will dissolve in solvent and temperature. In here, solid is undissolved or no more solution dissolves. Saturated. It contains less solute than solvent has the capability to dissolve. Supersaturated. More solute dissolved than in saturated solution. Crystallization. Dissolved solute comes out of solution and form crystals. This happens when you apply heat. There are also types of solutions based on the amount of solute. The concentrated and dilute solutions. So what are these? Concentrated is having lots of solutes in a small amount of solvent, and dilute is having a small amount of solute in a large amount of solvent. Just like example, imagine that you are making a coffee. Ang outcome is either concentrated or dilute solution based on the amount of coffee nga imong ipa-dissolve. We can say that the solution is concentrated if piso ang imong kape. Ihurot nimo ang isa ka sachet sa kape and half ra sa mug ang kadaghanon. In this, the outcome of color is dark, while in dilute solution, mas daghan ang tubig kaysa coffee granules. Therefore, the outcome is lasaw or light ang color compared sa concentrated solution. But without factors that affect solubility, change, may it be physically or chemically, will not be possible. First is temperature. It affects the solubility of both gases and liquid. Gas in liquid. Solubility increases with a decrease in temperature and decreases with an increase in temperature. Solid in liquid. This is where endothermic and exothermic reactions take place. What are these? Endothermic reaction. Solubility increases with an increased temperature. Exothermic. Solubility decreases with an increase in temperature. Second is pressure. It only affects the solubility in gases, like when you shake your sealed bottle of soft drinks. The carbon dioxide is under high pressure. Bisan pag di siya i-shake. Also, soft drinks have a lot of dissolved carbon dioxide. So when the sealed bottle is open, ma-release niya ang pressure and some of bubbles comes out. Third is increasing the surface area increases the solubility of a solid because a larger number of molecules have contact with the solvent. The greater the surface area, the greater the interaction between solute and solvent. And last is stirring. It increases the solubility of solid in liquid.
I will discussing chemical properties. What is chemical property? A chemical property is a characteristic of a particular substance that can be observed in a chemical reaction. Chemical properties. The properties in which the chemical composition of the matter changes. Chemical properties are generally irreversible. This is the some chemical properties. The flammability, solubility, temperature, melting point, and the boiling point. Flammability. It is related to the burning of the compound. Solubility. It is related to the mixing of one compound into one another. Temperature. It is related to the hotness or coldness of the system. The melting point. It is the temperature at which a solid starts converting into liquid. And the boiling point, it is the temperature at which vapor pressure becomes equal to the atmospheric pressure. This is the uses of chemical properties. Scientists use chemical properties to predict whether a sample will participate in a chemical reaction. Chemical properties can be used to classify compounds and find applications for them. Understanding a material chemical properties help in its purification, separation from other chemicals, or identification in an unknown sample. The difference between chemical properties and physical properties. While a chemical property is revealed only by the behavior of a substance in a chemical reaction, a physical property can be observed and measured without changing the composition of a sample. Physical properties include color, pressure, length, and the concentration. This is the examples of chemical changes. A new compound results from a chemical change as the atoms rearrange themselves to form new chemical bonds. A chemical change always involves a chemical reaction. The starting materials and final product are chemically different from one another. Here are some examples of chemical change. The burning wood, storing milk, digesting food, heating sugar to form caramel, baking a cake, and the rusting of iron. That's all for the chemical properties.
The strength of the solution is defined as the amount of solute in gram dissolved per liter of the solution. It represents the strength or concentration of the solution. It expresses in grams per liter. For example, suppose 10 grams of glucose is present in 1 liter of solution, then the strength of concentration of the solution is 10 gram per liter. Hence that first we know that a solution is a homogeneous mixture of two or more substances in relative amounts that can be varied continuously up to the limit of solubility. It mainly comprises two components, namely solute and solvent. The term solution is commonly applied to the liquid state of matter, but solution of gases and solids are possible. The strength of acids and bases depends on how much an acid or base ionized in solution. A strong acid or base completely ionized in solution. In a neutralization reaction, an acid and a base react to produce a salt. Strength of the solution is the amount of solute in grams that is present in 1 liter solution. There are many quantities that represent the strength of the solution, which is normality, molarity, and morality. The strength of the solution can be represented by formulas as strength of solution equals mass of solute in grams over volume of a solution in liters. Note that the strength of the basic solution will depend on the concentration of oxygen-hydrogen negative oxygen-hydrogen ions. So, if the concentration of oxygen-hydrogen negative oxygen-hydrogen is more than means it's more basic, and if the concentration of oxygen-hydrogen negative oxygen-hydrogen is less, that means the solution is less basic in nature. Hydrogen chloride is described as a strong acid.
Strength of a solution, molarity and its formula. The molarity of a solution is calculated by dividing the moles of a solute by the volume of the solution in liters. Let us learn about molarity in detail. Methods for calculating solution strength. The amount of solute in grams present in a 1 liter solution determines the solution strength. Normality, molarity, and molality are the terms used to describe the strength of a solution. The strength of the solution can be characterized by the formula for molarity. Mass of a solute in grams over volume of a solution in liters. Strength of a solution. Solute's mass in grams over volume of a solution in liters. Solution concentration. If the volume is measured in milliliters, multiply the total formula by 1000. Solute mass in grams over solution volume in ml times 1000 solution concentration. What about syrup? Though, which of the following has 60% sugar and 40% water? Is sugar going to be the solvent? Even though the replies are no, the sugar is still a solute. So, what is the proper definition for this situation? Solvent is the component of the binary mixture that is in the same physical state as the solution. A binary solution consists of two components. The solvent is the component that is present in greater quantities, whereas the solute is the component that is present in minute quantities if the physical state of both components are the same. Methods calculating solution strength. Mass percentage. The term mass percentage refers to the number of parts by mass of solute per 100 parts by mass of solution. Mass percentage, weight of solute over weight of solution times 100. Volume percentage, several parts by volume of solute per 100 parts volume of the solution, it's the volume percentage. Volume percentage equals volume solute over volume of solution times 100. Molality, the number of moles of solute dissolved in 1 kilogram of solvent is known as the molality of solution. Molality M, moles of solute over weight of solvent in kilograms. Molarity. The molarity formula of a solution is the number of gram molecules of the solute present per liter. The concentration of a solution is stated to be a molar of 1 gram of solute molecule is present 1 liter of solution. Molarity formula. M equals number of moles of solute over volume of solution in liter. Normality, the number of gram equivalents of the solute present in 1 liter of a solution is known as a solution normality. The concentration of a solution is stated to be 1 of the normal if 1 gram equivalent of a solute is the present in 1 liter of a solution. Normality, N equals number of gram equivalent of solute over volume of solution in liter. Mole fraction. The mole fraction of any component in a solution is the ratio of that component's moles to the total moles of all components present in the solution. X solute equals N over N plus N. X solvent equals N over N plus N. N equals moles of substance. N equals solvent in moles.
Conclusion. The ratio of the amount of solute dissolved in the solution to the total volume of the solution is the strength of the solution. A solution's strength can be expressed in terms of ratio, fraction, or percentage. The formula for molarity is represented as moles of the solute per kilogram of solvent. Units used to vary dilute concentrations of solute include parts per million, parts per billion, and parts per trillion. The kind and amount of intermolecular interactions are significant in solution composition.
Good day, everyone. I am Ira May Gulchano Ayag,
And I am Claire Achacoso.
and we're here to discuss our designated topic about units of concentration of a solution. So first, what comes in your mind when you talk about units of concentration?
Or do you know what is units of concentration? Units of concentration of a solution can be defined as when a mixture of one or more solute is dissolved in a solvent. The units of concentration includes molarity, molality, mass percentage, parts per million, parts per thousand, and parts per billion.
So first, let us discuss what is molarity. Molarity is the number of moles of solute per liter of solution. So when we say if we dissolve salt and water individually, the salt is the solute, the water is the solvent. The solvent dissolves the solute, and together the combination of the solute plus the solvent is the solution. So keep that in mind that it helps you to distinguish the solute from the solvent. So here is our example. What is the molarity of each solution? 0.25 mole of sodium chloride in 300 milliliters. Our formula is M equals mole solute over L of solution. To get this 0.3 liters, you need to convert first 300 milliliters. So 300 milliliters over 1 times 1 liter over 1000 milliliters is equal to 0.3 liters. So M equals 0.25 mole over 0.3 liters is equals to 0.83 mole. So that is our final answer.
what is molality? Molality or molar concentration is the amount of substance dissolved in a certain mass of solvent. It is defined as the moles of solute per kilograms of solvent. So I'm gonna give you an example for that for molality. So here it is. Here are the example of molality. So 128 grams KBr or potassium bromide is dissolved in 925 grams of water. What is the molality of KBr solution? So here is the equation. Molality is equals to moles of solute divided by kilogram of solvent. And solvent. Let's identify what's the solute. And the 28 grams KBr is the solute, and 925 grams of amount. So we can convert the solute into moles and convert the solvent into kilograms. The easiest way to convert grams to moles is to divide by the molar mass. So we'll just divide it by the molar mass of KBr, which you can find by looking at the periodic table. So it's 119. So 128. So 128. So 128 divided by 119 is equal to mole. Is equal to 1.08 mole. Equal to 1.08 mole. So to convert from grams to kilogram, you just divide it by them. So 1,000 or 1,000. So 925 divided by 1,000 is equal to 0.925 kilograms. 5 kilograms. So then we have the moles and the kilograms. We can just plug it on equation. So molality. So here it is. So molality is equals to 1.08 moles divided by 0.925 grams is equal to 1.16 mole. So here is the result of molality. Here are the examples of molality.
Next is the mass percentage. For a solution, the mass percent is described as the grams of solute per grams of solution, multiplied by 100 to get the percentage. The mass percent formula is expressed as solving for the molar mass, also for the mass of each element in 1 mole of the compound. To calculate the mass percentage, the mass percent of an element in a compound, we divide the mass of the element in 1 mole of the compound by the compound's molar mass and multiply the result by 100. So here is our example of solution composition of mass percent. So our formula is mass percent equals the mass of solute over the mass of solute plus mass of solvent times the 100%. To get this mass of solution, you just simply add the mass of solute plus mass of solvent. So mass percent equals the mass of solute over the mass of solution times 100%. So our example solution is the 15 gram of sodium chloride and the 100 ml water. You just need to convert the 100 ml to 100 grams. So mass percent equals 15 grams. And to get this 115 gram, you just simply add the 15 gram of sodium chloride and the 100 grams of water. So 15 gram over 115 gram times 100%. So our mass percent is the 13%. That's our final answer.
What does parts per thousand mean? Much like percentage, parts per thousand or PPT is a ratio often used to refer to the concentration of solute in solutions, such as salts in water. To calculate parts per thousand of solute in solution is to express the concentration as milligrams of salt per grams of solution. 1000 grams equals 1000 milligrams. That numbers gives you the parts per thousand by mass.
That's it for our presentation. I sincerely appreciate your attention. I hope that you'll take some valuable information from our assigned topic about solution. Thank you.
I know you love, she's a